So, hello everybody to our lecture in statistics after my software has updated. Um, yeah, we are at the topic price indices and how to measure a price level. So, the aggregation of a price level, and there we discussed, well, we could just calculate the arithmetic mean of prices 11 plus 10 plus 33 divided by 3. Should this be our price level, or we calculate in this example just total consumption by summing up 11 times 4, 10 times 10, and 33 times 2. Does this create our price level? And there we discussed, well, we just want to cancel out the price movement, and therefore we then started to calculate. Then, since we want a measure where we only have the so-called quantity effect, that we have two possibilities, and the first one would be that we take the quantities of the actual year of 2015 and we weight them with the prices of the next year, comparing this with our consumption in the actual year 2015. And this price level measure, this was introduced by Laspire. And then, of course, we can do it also the other way around, that we just calculate the basket of in the future of 2016, taking the prices of the former year of 2015 and comparing this then with the total consumption in 2016. So in the first case, we more or less take 2015 as a base, and in the second case, we take the forward price system of 2016 as the base. And so in this case, we calculated the quantities of 2016, 8, 4, and 3 with the prices of 2015. And this was introduced by Parsche some 100 years ago. And these are two logic possibilities how to create a price level. And actually in economics we use both, because the Laspire index is mainly used when we calculate the consumer price index, while we use a Parsche index when we calculate the wholesale prices in an economy, and this we call then the GDP deflator. And what we can then consider is how is this done. And when we look in the formulas, then we see that the Laspire index is nothing else than a weighted arithmetic mean with the weights where we take the proportion of the specific good I, relative to total consumption. So this proportion is the weight, and then we just calculate more or less the weighted arithmetic mean. And if we look at the formula for the partial index, then we see that we take the inverse with the same weights, but now from the forward-looking perspective, because now you have to look at here that now the index T is in the denominator, and we calculate the proportion now of the single good I relative to the total consumption, but now due to the time index T and not to the time index 0. So let me mark this also with a new color, violet. So the difference is that the partial index, we take the inverse, and taking the inverse then means that we are calculating also a weighted mean, but now it is the weighted harmonic mean, and the proportions are calculated relative to the year T, while the proportions taking the last pair index is calculated relative to the period T equals 0. Okay, and then we talked about the properties of these two price levels. Well, and since we come from the past, then we can say that in general, with the last payer index, we will overestimate the general increase in the price level, while we should not be surprised when it is the other way around, when we calculate the price level with the partial index, that in this case we will underestimate the increase of the price level. Well, and what can we do? Of course, if we have one index which is overestimating what we want to estimate, and the other index is underestimating what we want to estimate, what is then a logic idea if we have these two estimators? Well, if we take the mean of these two estimators. So if we have here an overestimation, here an underestimation, then we take this together, and then we can think of, in order to overcome these problems, calculate the mean of the two estimators. And surprisingly, of course, this is done in statistics. And this is then called the Fisher index. Well, and then what kind of mean do we take? We take the mean square root of the product. And do you know what kind of mean it is if we have two numbers multiplying them and taking the root. This is the so-called geometric mean. So what is maybe the nice thing if we look at these price level estimators, that we have the three general means which we know from our introductory courses in statistics. So here, Fisher index is a geometric mean plus prior index is an arithmetic mean, and the partial index is a harmonic mean. And well, if we calculate this mean in our example, then we just multiply our 0.98 times 1.28, taking the square root, so we obtain Fisher price index of 1.26. And of course, also we use this price index in economics, and especially, well, it is not totally the same how we do the price adjustment of economic time series in Europe and in the United States, because in Europe we, and this I told you, we calculate in Europe, GDP deflator is calculated via a partial index, and this we will also do in a minute, while in the United States, and also I looked it up also in Canada, the price adjustment in economics time series or of GDP is done via the Fisher price index. And this actually one also has to know when we are comparing growth rates in the United States with growth rates in Europe, that we use two different methods for the price adjustment. Okay, then of course here I said to you what we right now are doing is that we used always a base year. In the partial index it was 2016, while for the last payer index it was the year 2015. And then if we go on in time, then of course, since also our products are changing, some products vanish, we invent new products, and also the quality of products is changing, then we would have a problem if we still take maybe the base year of 2010 or 2000, because in the year 2000 we had other products than in the actual year 2022. And therefore, in history, we made just an adjustment that we always changed the base year every 5 years. But this also means that in general, every 5 years, we had to recalculate every growth rate due to the change of the base year. And therefore, then our time series wouldn't be stable when we are changing the base here. And therefore, roughly 20 years ago, we changed our concept that we started to calculate, especially for GDP, always to calculate the today quantities with the prices of the former year. And this means then that we are creating a so-called chain index. And this then means that we reduce our problems we had. I recommended here with the last pair and the partial index, because the overestimation and the other underestimation just comes more or less from our behavior, that if prices of goods are changing, then we start to substitute our consumption from one good to the other. And these substitution effects are minimized if we, so to speak, always every year we are moving the weighting due to the concept that we are always taking the prices of the former year. And here I wrote it also down that with a fixed base year, and this is really a bad thing, that the time series for growth rates are not stable. So I always had to recalculate every 5 years, and therefore we switched in general in economics to the so-called chain indices. And for this, then we can now, in the actual definition of GDP deflator as a partial chain index, and there we define this, that we take the so-called real GDP, and real GDP of time t means that multiplying quantities of time t with prices of time t minus 1. So in general, here I wrote it in detail down, that the index of nominal GDP, here just multiplying prices of time t with prices of with quantities of time t. And since we want to have an index, we calculate this relative to the nominal GDP of time 0. But this is only fixing that we afterwards obtain an index, and then we multiply this number with 100, because in general we want to have an index in the neighborhood of 100, while the real GDP index, and this is now the chained index. And where do we see the chaining? Well, we take here, as I said, quantities at time t times prices at time t minus 1 divided by the nominal GDP of the former year, And now multiplying this with the GDP, real GDP index of the former year, C minus 1, and this is the chaining. Well, then you can think of somehow I have to start, if I'm always going backwards one period and I need this number, then I wouldn't have such a number because I always have to go back 1 year in history. And well, therefore I have to define a starting point. And for this, therefore, we need a starting point. And this means we define a specific year in history equal to 100. But the nice thing is, since we are interested when we pose economic questions, mostly not in the absolute values, but in the growth rates, just using one specific year, setting this to 100, of course, doesn't change the growth rates. Though it doesn't matter if we choose 2015 as 100 or if we choose 2020 as 100. Let me write also this down. But this does not change the growth rates. Oops. So, and then if we look in detail at this formula, then this one would, because if we look at this formula, I think it doesn't directly see that this is a partial index, and therefore we can rewrite this in this form, and then again we see that in this case we get our weights and that this is then a partial chain index. I have to write down now. Okay, well, all this seems to be quite theoretically, and to give you a practical example, we go to the next slide, and within this slide we want to take this example and just to see it that we want to calculate the growth rate of the GDP deflator, and since we have here 4 years at least we also want then to calculate the average growth rate, so the average price movement over the last 4 years. And this, of course, we again want to do in Excel. So I copy this, go into Excel. Oops, This is a bit too wide. Let's shorten this, that you can see it. Oh, this still you can't see. So then let's go until here. And this we make also a bit smaller. And this one. And this one. This one. And this one. Now you see everything. Okay. And we can go back into also the years. So now what you see here, I think you know this from your macro courses. This is just the expenditure approach of GDP, private consumption, government consumption, grow investment, and exports and imports. So GDP is then, of course, private consumption, expenditure for private consumption, government consumption, grow investment, plus exports minus imports. So what do I have to calculate when I want to calculate nominal GDP in the year 2018? Any idea? Well, GDP is just what we have produced and then consumed in a specific year in a country at actual market prices. So what we have to do is 1.1 times 10, 1 plus 1 times 3 plus 0.9 times 3 plus 1 times 12 minus 1.1 times 10. So let's start. So 1.1 plus times, oops, not plus, sorry, times 10 plus 1 times 3 plus 0.9 times 3 plus 1 times 12. And now imports have to be subtracted minus 1.1 times 10. So this would be then GDP in 2018. And since we have now here our formula, we just can copy this formula and we are going downwards. So, and now real GDP. How do we have to do this? Let's go in our, oops, definition. In this case, what we have to do is that we have to calculate quantity of time t times prices of the former period. And doing this then means 2018 we cannot calculate, but in the since we do not have the prices of 2017, so we can start here in 2019, and then we have to calculate quantities of 2019, 11 times 1, 4 times 1, 4 times 09, plus 13 times 1, minus 12 times 1. So let's do it. That is then 11 times 1 plus 4 times 1 plus 4 times 09 plus 13 times 1 minus 12 times 1. And of course also this we can just copy downwards, and then let's move to the right. Now we have nominal GDP and real GDP. And since we define this via an index, let's move this one at this part. Then we need the index. GDP num and bit more to the side, and we need the index GDP real. Then we use the starting period. In this case, we take this as 100 and this as 100. This means what we are doing, when we want to calculate the BIP deflator, this is just nominal BIP divided by real BIP times 100. So let's do this. Nominal BIP divided by real BIP times 100, and then we need the increase of 17.7 up to 21.88. So in this case, we obtain 21.8 divided by 70.7 times 100. This is going up, and here nominal divided by real GDP relative to our 100. So we obtain, nominal GDP divided by real GDP times our 100, moving this downwards, and then the relation between our two indices means nominal divided by real times 100 is our GDP deflator. And what else we wanted to calculate was, I think, the growth rate of the GDP deflator. So next one, growth rate GDP deflator. This would be then here, of course, in the first case, we just can look it up, 7.3%. This would be then 107 over 100 minus 1. And let's do this as percentage. And in the end, we want to calculate average growth rate of GDP deflator. And for this, of course, since we have growth rates, which kind of mean do we have to use when we are averaging growth rates? Well, if I ask just this then doesn't mean that we can just add up these three numbers, 7.11 minus 11 plus 15 dividing by 3, but we have to use the geometric mean of the inflation factors or the growth rate factors. So what we need is the growth rate factors, and this is just 1 plus the growth rate. Oops. Copy. Yeah, we don't want to have the percentage format. So just numbers, and then taking the geometric mean of this minus 1 equals geometric mean of these three numbers. Then we have the average growth factor, and in order to obtain the average growth rate, of course, we have here also to subtract 1, and this would be then the growth rate, and also in percentage, and let's also put 1 digit in the end. Oops. This we can do later on. Okay. This is then one example how we do the price adjustment in an economic time series, because we want to get rid of the price effect during our consumption process. Or if you go to an enterprise, then of course you are also interested in the real growth of your company, and not only what is that you do not want only to look at the nominal numbers, because maybe in the nominal numbers you see only or mainly the price effect, especially if we are looking at our actual times where we have really high inflation rates of 10% and more. And if you go also to some specific goods, then of course you see there are even higher growth rates in prices. And well, there you also have to have an eye in your company that maybe you are selling much less quantities, but your revenue is still the same due to higher prices right now. And if this would be really a sustainable growth during time, there, of course, we have to make a question mark. And especially if you look at the automobile sector in Germany right now, then you see that the large companies in Germany right now have very high revenues, but these high revenues are mostly driven by the higher prices of the cars which we sell right now. And well, if you don't sell more cars than before in quantity, we will see if this would be a sustainable strategy. Okay, that's for today. Up, and then we will see the next